All right, hi everybody, my name is Brian. I am a supplier marketing manager at a company called TTI in Fort Worth. So what that means is that I basically work with our salespeople. We have like 300 salespeople throughout the US, and then they work with customers that design circuit boards. So everything electronic that we use, we really try and influence design and get them to use our suppliers so that we can sell them product to go on their circuit boards. So I work with sensors specifically. So a lot of my customers are looking to maybe add new features to their devices or learn about some new technologies. And that's kind of my specialty. What's the newest, what's the greatest, what's the best product? So I'm not an engineer. I went to business school and started doing sales in electronics. So I'm from Minnesota. I had that territory, the Dakotas in Minnesota. So I was in the car driving a lot. But then after that, I started working with a lot of connectors. So your USB connectors, your HDMIs, Ethernet, things like that. And I actually helped develop the USB-C connector for Worth Electronics. So you'll see that on the new MacBooks and things like that. We probably worked on that almost 6 years ago, and you've probably only seen it over the last 2 years. So a long development time, a lot of new things happening. But so what I'm going to talk about today is a little bit of just industry. What's some of the new things happening related to sensors and wearables. If anybody ever heard of the Internet of Things? Or IoT? All right. So I'll tell you a little bit about that, and it's going to be in our industry. It's a big trend. It's kind of I'll explain more later. And then sensors, wearables, and then I'm going to focus on. I brought the sensors that the students may be working with the Flora on, right? So I'm going to tell you how those work, where you can use them. And maybe give you a little better idea what you want to do for your project. So I have all of this stuff out as well. So who has their Flora boards? I don't want to get anybody in trouble. But
do we need them with us?
No. I'll just pass these around then if you guys don't have them with, just so you can see some of these parts. So on most of these little boards, right in the middle will be where the sensor is. So they're really small. There really aren't much to look at. It's a tiny little chip, but it gives you an idea on the size and really how these things are working. And then I'll kind of explain, why are they this size? Things like that. So, all right. So I'm just going to give you a little bit of an idea of my company and what we do. So we were founded in the 70s by a guy named Paul Andrews, and he actually still owns our company. A very, very wealthy man and has done very well over the years. But what we do, like I said, is we work with customers to design in product, help them on the design side, but then we also have a monstrous warehouse where we ship out components and we help them with their supply chain. So through the 70s and 80s, that was really our expansion time, adding a lot of different types of products. And then you can see, we've kind of at 2000 expanded into Asia. For a majority of this product, that's where it's all manufactured, is Asia. Especially when we get down to this very small component level, the only way to make that price competitive at this point in time is to manufacture it there. And in 2000 also, has anybody ever heard of Mouser? Okay, so they are a company in Mansfield, and TTI bought them. So what Mouser does is they have a website with every part available ever, basically, and you can just buy online. So we have that capability at my company as well, but we're more face-to-face. You call somebody up and talk to a person. At Mouser, it's a full website, and that's it. And that's really where the trend has been going. So to just give you an idea, since 2000, TTI, in the US alone, we do over $1 billion, like $1.2 billion in sales. And then since 2000, Mouser has actually caught up to us because the trend of engineer and just people in general is that we want to buy online. I don't really need your help. Don't bother me. I'm the same way, so I understand. But when projects get bigger and more in depth, you need that person-to-person contact. And that's really why TTI, I deal a lot with like Boeing, aerospace companies, military companies. They need that level of service. So we kind of have, I guess, both sides, online only, person to person. And then in 2006, we were actually bought by Warren Buffett. So that's been great for us. He just provides, I mean, more money. We can build a bigger warehouse, put more product on the shelf. And then kind of another little niche is we acquired another company called Sager. And what they focus on is really heavy industrial style products. So where we're talking about really small components, like something on the middle of this board here, what they sell is a big pressure transducer, something you would see maybe on like a heavy duty vehicle or a factory floor or something like that. All right, so the Internet of Things. This is my most hopeful and also most hated trend right now because everybody is talking about it, but it hasn't totally caught on yet. So when we talk about the Internet of Things, this is a Fitbit, for example, talking to your phone. I went to a show last year and I saw a dog food feeder that connected to Wi-Fi, and you could feed your dog on your phone, right? It cost $250. So we have a device like that replacing a $5 dish, partially because we're lazy, but partially also because technology's just allowed us to do that at this point. So a lot of things that, I focus on personally. I am not working on high-end fashion projects on a regular basis, so I don't want to give you that perception. I work a lot with like medical wearables. I have a company that does wearables for like warehouse workers. You can track how efficient they are and things like that. So one thing I really think is cool is just machinery in a factory, for example. 10 years ago, those devices did not talk to each other at all. But now every machine in that factory is communicating with each other. So the power consumption in the factory is much lower than it used to be. The people are more efficient. Just all processes are much more efficient. So when we're talking about, politically right now, we're talking about adding all these factories, right, to the US. I can tell you right now, there's not going to be very many people in those factories working because everything is automated. And that's what I do for a living. So, you might have 5 people, but you're probably going to have 500 machines all acting by themselves. And each reaction by that machine influences another machine. So it's really just a lot of data overall. So I kind of mentioned some of these things, but in our industry with these really small components, you could build 1 million of them and end up throwing 50,000 of them away because they just don't work quite right?
We experienced some of that when we opened up our Flora kits.
Right, exactly.
Yes.
Yeah, so when those factory machines are talking to each other and something goes wrong, it reduces that downtime and reduces those failures in the products. So they can almost catch it before things go wrong. Another big thing, like I showed you guys this big part, right? So in the past, they would just have a small connector here and then there would be a cable going to something else that's taking and processing all this data. So at this point, they're adding a Bluetooth module and a little battery on there. So if you think of like a HVAC unit on the top of the building, so that technician, if something goes wrong, he can just stand on the ground with his phone, get what this is saying, and not ever have to crawl up the ladder to get up there, right? So he probably just saved himself an hour. So this is really, these small little changes, it's not a huge change in technology, but just to kind of give you an idea what I guess we're seeing with our customers. So, all right, now I'm going to talk a little bit more about just sensors. So a sensor basically will have 3 general functions. So the first one will just be monitoring. So you can see I have like a tire gauge pressure meter, right? So you plug that into your tire, the little screen's gonna tell you how much pressure is in your tire, right? Nothing too exciting. Feedback and control would be if you use that same pressure gauge, but it's hooked up to an air pump and it automatically fills your tire to whatever you want it to be. So there's still nothing manual there, right? And the third, and really where I see a lot of my work happening, is where they're trying to add intelligence to old devices. Kind of like we talked about the dog food feeder, right? They just added a whole new function that you can go onto your phone, feed your dog, and that's that. So I worked on another cool device that was actually just a regular street light. So a lot of street lights have a little sensor on them. When the sun's going down, they turn on, right? So with this one, they actually added another sensor that is the same sensor that's in your bumper of your car, so that they were able to sense how many cars were passing by a street light. Why would they do that? Anybody have an idea why they want that information?
Traffic patterns.
Traffic patterns is one, but they sell it to real estate developers and city planners, because outside of Google and GPS style companies, nobody really has that. Oops, sorry. So they sell that data for actually more than they sell the streetlight for. So it's crazy. They can sell the streetlight one time, but they can sell that data every single year. So kind of cool, kind of scary. All right, so a lot of the sensors that we'll talk about, and a lot of them that are used on the floorboard, are what they call MEMS technology. So what MEMS is micro electromechanical. So this is a technology of basically tiny microscopic products. So you can kind of see this little diagram down here. That's basically what's going on in what we call an accelerometer. So in your cell phone, when you flip your screen, right, the orientation of the screen flips as well, so you can read it wherever you're holding it, right? That's an accelerometer. That's what does that. If you have a Fitbit and it takes your steps, also an accelerometer. So it's really just taking that little vibration and creating data behind it. Another version is basically a flexible material that's doing the same thing in a different direction. So I really just kind of show you this to also talk about the size. I mean, these things are absolutely tiny. If you see these boards, I'm just gonna leave them in these bags, but if you guys wanna pass these around, I mean, they're like 2 millimeters wide. They maybe cost 25 cents. You know, they're very standard types of products. Okay, a couple different ones as well. I kind of categorize generally on our sensors. So we talked about the accelerometers, the biosensors. Again, if you have a Fitbit, you see that green light flash at the bottom, right? That would be a biosensor. And really what they're doing there is testing, they can test chemicals. I've got some CO2 stuff as well. I'll show you guys that in a second. Image sensors on the floorboards, we've got UV, we've got red, green, blue sensors. And then we've got motion detectors. When I mentioned the street light, that's a good example. If you think about your sink or a paper towel dispenser, it's always using motion and light. So one thing I will say right now, I'm used to talking to a group of engineering nerds. So if you guys are not understanding or want me to explain something a little more, just please, raise your hand or ask a question, because this is a new type of group for me.
They just want to play with your toys.
Right? That's the best part anyway. All right, so just a couple things to remember and a couple trends in electronics right now in general. Everything that we see takes voltage to run it. We either are going to have to plug it into a wall, we're going to have to use a battery, but some way there has to be voltage to these products. So it's just something to think about, especially in fashion, because you don't want a big bulky battery case on the side of the belt or something like that, right? You want it to be very discreet. You want to use maybe a small coin cell battery. So that really determines what types of sensors that you can actually use. The second thing is actually not even product, but a very important with sensors. It's very standard product. All of the, well, I guess a good example is what makes a Fitbit different from 100 other wearables, right? I guarantee they're using pretty much the exact same stuff inside, but it's all the software. It's all their algorithms that make it more accurate or less accurate. And it's also the marketing. Which one do you buy? Which one looks better? All right, and again, all of this is data. These sensors are basically providing data. What is that device doing with it? How safe is it? Is it secure? That's really some of the concerns right now in the industry, because there's not a lot of security behind this data. Ultimately, someone can easily hack into your Apple Watch, anything you have on your body, your medical devices. It's very simple. And the next one, just
before you move on to the next slide, Brian, when you are selling the components, are you also working with the customers on the coding? Like when you talked about the algorithms and the
not
software?
me personally.
Right.
Nope. So my company actually does basically the hardware only.
Okay.
So that's really where they typically need assistance, because a lot of the newer engineers are more proficient in software than they would be in making these parts, because that's where the money is.
Right.
I would do the same thing. If I had to go back to freshly graduated from college, I would go into software rather than hardware. Let's put it that way. It's much more lucrative, and I think that's where the future is also going as well. So the next one is size matters on this stuff, because you cannot use a sensor that's, especially on wearable small devices, that's very big, because it has to be powered and it has to fit in a small package. You don't want something that is 4 inches wide that you're wearing on your wrist all day, right? Okay, so just a couple visuals here on the wearables, just to kind of give you an idea on what goes inside. So typically they're using an optical sensor and a motion sensor. So the optical sensor would be that green pulsing light, and what that really does, you can kind of see down here, it's just emitting and receiving a light. And based on how your blood vessels fill, and honestly, too technical for me, but it's based on what your blood vessels are doing, and that gives you your your heart rate. And then on the motion sensors, I mean, we do a lot of just general accelerometers, because that takes care of your steps. And actually, there's been some advancements where they can use these accelerometers to also get your breathing patterns. So I'll show you a couple examples of those later as well. Okay, so my videos here, I don't know if they're gonna work or not. It doesn't look like it. So this particular one, I am going to pull up quick.
My name is Kenneth. I'm 15 and I live in New York City. I love being outdoors and hanging out in the park with my friends. I love hiking, exploring, and swimming. But above all, I love solving problems. I grew up in a home with 3 generations of family members, and we've struggled with one problem in particular. My grandfather has Alzheimer's disease, and a few years ago, he began wandering at night, causing a number of accidents. My aunt, his primary caregiver, tried to stay awake, but it was hard to catch him leaving the bed. That's where the inspiration for my project came from. I wanted to create a simple system that could immediately detect any wandering. But how? Then one night, I was daydreaming, and I saw my grandfather stepping out of bed. The moment his foot landed on the floor, I thought, why don't I put a pressure sensor on his heel? I've been working on the idea since 2012. I started by creating a sensor that could measure pressure, but it also had to be thin and flexible enough to be worn on the heel or in a sock. I then learned how to design a very small circuit that could create a wireless signal. Finally, I had to code an app so the signal would trigger a sound in my aunt's smartphone, waking her up. My device has caught 100% of my grandpa's wandering, and he no longer has accidents. It's brought my family peace of mind. And it's made me even more excited about solving problems. I really want to continue to help our aging society. It would be great to explore neuroscience and the mysteries of the brain more. My grandfather is just one of the 36 million Alzheimer's and dementia patients in the world, and my dream is to find a cure.
All right, so there's a couple reasons I like to show that video. So one of them is because he's 15, and it's pretty cool that he came up with something like that. But also because he probably used $10 worth of parts to make that. That one, oop.
Yeah, you need to close that up. Yeah, there you go.
Oh, no, that's okay. So what he really did was take these really standard parts and he built it around software. So again, probably $10 worth of product, and he is going to be able to charge probably $100 for that thing because of the software. So another thing is that he mentioned that he caught 100% of those occurrences. That does not happen with anything where there is going to be mechanical contact. So if you think of like a switch, if you were to put a little push button switch on the bottom of his heel instead of a sensor, there is no way that you're gonna catch 100% of those times, because maybe he's off to one side a little bit, it's not a perfect little push. But that's kind of what we had to work with 10 years ago, were little electromechanical push button switches instead of a lot of sensors that we have. So this is just kind of a little view here of what he did. So again, we got a coin cell battery. He put a Bluetooth module on there and the pressure sensor, and that was really about it. So, you know, working with a lot of app development tools, you can easily make devices like this work. So a couple different things. He had a couple different versions. His first one was actually just pretty basic, you know. He took it and taped it on his grandfather's heel, but then he actually incorporated it into a sock. So pretty cool use of the technology. And one other thing I like about him is that he's focused on that aging generation. So in the US right now, I think it's over the next 10 or 20 years, I can't remember the time frame, but the population of 65 and above is due to double. I mean, this is fantastic for an assisted living facility or a home care for the elderly, where they don't want security cameras in their bedroom. You know, that freaks people out. But something, you know, discreet and non-invasive like this, they'll sell millions. Okay, so one more.
Are there special care considerations as far as washing the product afterwards, or the sensor has to be removed? How does that?
Yep, so I think what he did on this one, you can kind of see they did like a snap-on thing to the sock almost, so I'm guessing that was for that reason. But this sensor style right here where they have, it's almost like flexible, those are fully sealed. So you can use the nastiest glue on those things and it won't phase them at all. It won't affect it. So a washing machine or something like that, you could do the same. Yeah, so the main problem is going to be right in this area where it goes from sensor to circuit board. So the connectors there, I mean, you can go with a very basic connector and save a lot of money and get no waterproofing at all, or you can spend more and get a better product. There's a lot of range there. So I work with some customers as well that'll use all standard product, and then they'll just fill in with like an epoxy material, and it just is like a soft plastic that just seals it all up. So it just kind of depends on how much space you have to work with, what kind of connectors you have, and what kind of sensors. So a lot of different things there. I think that's all I've got on that one.
Has he started selling these songs?
At this point, I think he's probably like 19. I'm sure he's at MIT or something, but there's another company that actually bought this design from him that is going to start, manufacturing these now.
Full scholarship.
I'm sure. It's kind of scary. I'm always like, I probably won't have a job in 10 years. It's going to be bad. So have you guys been on Adafruit at all and kind of looked at some of the things that they've been doing there? Okay.
My group has, but that's not necessarily true for the other
Okay.
students in the audience.
Perfect. Well, some of this might be, some of the same videos that you've seen in the past, but they are good examples. And I'll point out a couple specific things there on them as well. So the next thing I'm going to talk about are the accelerometers. And this is probably one of the most commonly used sensors in wearables, and I would imagine in garments and things like that as well. Okay, so here the accelerometer is this little component here. They make it look kind of big, but it's really like 2 millimeters, so very small. One of the things an accelerometer is really used for, if you think just walking, the pedometer is a big thing. But also I've seen a couple good videos where they're using it on design for costumes. So especially dance acts. There was one, I think they're on America's Got Talent or something like that. But their whole act was based off this software through the wearable sensors they had that lit up LEDs in their design, and different color LEDs. So part of that, they did the accelerometer. So one thing with an accelerometer, people always think it's how fast you're going, right? Because that's what we think about acceleration sometimes. But it's really more so of subtle vibration that triggers that output. And the compass would be more so of that, how fast and which direction are you going. So with the two of them, you kind of get that I'm going 20 miles an hour north. I mean, you could tell that from the data off these two together. So a lot of accelerometers will have a compass in it already, or a gyroscope in it already. So where an accelerometer is going to give you like an XY, like a vibrating axis like this, and a gyroscope is going to give you like a full range of motion. So I mean, a lot of like your gaming, your virtual reality headsets are using those types of sensors right now. There's a couple terms out there right now where they call it 6 degrees of freedom, where that would be an accelerometer and a gyroscope. And then they have one that they call 9 degrees of freedom, which is basically what all of our phones and everything is using now. So let's switch off of the motion sensors and the MEM style stuff. And what I'm going to talk about now are those more optical style sensors. So these are going to be influenced by light, UV. So this is a cool example. This is a UV sensor, and it doesn't actually just, I guess, absorb the UV light. It actually combines two sensors that are calculating that within itself. So it senses the amount of visible light and the amount of infrared light. So if you want me to explain the differences between those two, I can't. But it basically takes those two groups of data and combines them and gives you that UV output. So she did one really cool application with this where she took like one of those big Kentucky Derby hats, and she put the floorboard in the side of the hat, and she put the UV sensor kind of at the base. So all the sun coming down was going to that base of the UV sensor. And she had an LED ring, which basically would give you how much sun you got today. So do I need to put on some more SPF? Do I need to just get out of the sun? But a very basic application that they are actually starting to put into wearables, because I mean, especially Texas, Arizona, you know, it's hot. We get a lot of sun. Our skin is damaged from it. And there's really no good device out there to tell you when you've had enough right now. So, I mean, those parts are probably like $1.50. So to add that to the function on a Fitbit or some other electronic wearables is really not a big stretch. All right, a color sensor. So what this is going to do is they typically are just red, green, blue sensors, but again, they're gonna be just a tiny little what I would call dye. It looks like a very tiny little screen. And when an LED shines onto that target or to that sensor, basically that reflection will change if you link the sensor to, say, some LEDs, for example. I think she did a scarf in one of her examples. So she used a white fabric, put LEDs throughout it, and this sensor was kind of in the middle, so whatever shirt color she was wearing, the LEDs would match. So kind of cool. Works with a lot of different outfits, I guess. So. But okay, so this is actually one of my specialties that I work with a lot with customers. So it's not going to be available necessarily on your floorboards or a project like that. But I do a lot with like military simulation on here. So they do a lot of like airsoft guns and trainings like that. So we actually just developed a vest. So this is called piezo film. And that film is very flexible. So when that flexes, based on how much it flexes, it basically gives off a voltage or gives off power. So it's kind of cool because enough bend on that, you can actually power your floorboard without having to have a battery. So where we're using it in the military is that they basically have a little, I would just call it a impact tracker. So if you're shot here, it goes back to their software and it tracks where you got hit during your military simulation. So another way we're using it right now is in the medical field. So if you think about pacemakers or anything that's internal, at some point the battery is going to run out on that thing, right? I mean, they're going to have to go back in, get you a new pacemaker or whatever. So with that, it just extends the life because that power doesn't have to fully come from the battery. So if you have a little device that you can just put on your arm or when you're walking and it's flexible and creating power all day, you just added a day on your pacemaker or whatever it may be. So again, a cost-effective product that just can be used in a lot of different ways. So, okay, with the hand, you'll kind of see here. So we've got a grip and then he opens it, right? So when you plug this stuff into a computer, and what an engineer is going to be looking for is this voltage. So when he's releasing it, it's a negative voltage. When he clamps it, it's a positive voltage. So that's just okay, if I have a negative voltage, do this. If I have a positive voltage, do this. I mean, that's really where all that software comes into play. You can take that data and make it do about whatever you want. So a glove is another thing I've been seeing here where they are maybe powering some other wearables like that are giving you tracking or GPS or something like that, just based on your normal hand movements throughout the day. So it's kind of exploratory, but it actually got started on pinball machines. So I haven't seen one of those around in a while, but if you used to shake them, you would get the light that you were tilting it or whatever, right? That's what was doing that. And they'll use them on speakers as well. That's kind of another older technology, but this one is very cool. So anybody heard of Glastonbury Festival? Okay, it's in Europe. It's just a big music festival, but a lot of like EDM music, stuff like that. So what this company did was take this piezo film, and I'm not sure where they really placed it. I think it might be in this pouch here. But it also works with sound and very high frequency vibrations. So just standing in front of a speaker system, they rigged up this t-shirt. You could charge your phone just by standing there and getting the dB force off of the speaker, off of the music. So it vibrated that film at such a high frequency that it generated voltage. And they put this little thing here is basically storing that voltage, and like, this is just like a power supply, right? So they did the same thing. So all of that voltage goes to this, plug your phone in, you got power. So pretty cool. I mean, something that you really don't see all the time. It's not something you're gonna wear every day, right? But I've been to a lot of festivals, and the less you have to carry with you is the better. So if you can charge all your devices just by hanging out, pretty cool. All right, so now I'm gonna show you guys some applications and some wearables kind of that you might be interested in, but I want you guys to tell me, what you think is in this for sensors. So don't be afraid to be wrong, but shout something out if you have an idea. So I actually worked on this device it's a company out of Boston. I went in there there's a little USB connector on there. That was kind of my specialty at the time, but basically so you can charge this little turtle. So that little turtle sticks onto the baby, and when you wash it, you just take that out. That's why they have it detachable. But through that, you can get their motion when they're sleeping, their breathing habits, their heartbeat, are they awake? And they actually paired it with, or I guess partnered with, the smart thermostat manufacturer. So is your baby's temperature really hot at night? Well, let's turn down the temp in his room, and I never have to leave my bed. Pretty cool. And then they added the camera to it. So this is all kind of within the app, but you're getting sleep patterns for your baby, live video. I mean, as a parent, what more can you ask for, right? I mean, you may not have to get out of bed at 3 o'clock in the morning because you can just pull up your phone. So this company was started, I met these guys probably, 4 years ago, and they were younger than I was. I'm 30 right now. So these guys were fresh out of school. They sold this to Babies R Us by the time they were probably 25. So they don't talk to me anymore. So take a guess. What type of sensors would you guys think is in this application? So we talked about breathing and movement. So what would those be? Remember? Yep, accelerometers, but it would be that next step one, that 9 degrees of freedom. Yep. Because what this is doing is taking a full range of motion on that baby. So it's not really just a vibration for the breathing. Maybe they have one accelerometer in the device that's just for breathing and one that's tracking the motion. So.
What about the sensors for leaving babies in the hot car? That's a big problem.
Yep, and ultimately, I mean, this thing would do the same thing because they have temperature sensors in there as well, giving off the body temp. So, I mean, theoretically, I guess it could be the same thing. It's just they only make these on the onesie. So it would be almost a different type of wearable, I think, that they would
Also,
make.
I've read something that do the pressure, like, if your kid was still in the baby seat, and the pressure, an alarm would go off to say, guess what, you left your kid in the back seat.
Yes, yes. Okay, so what they do on the pressure so let's think about the car seat.
Yeah.
If we put a pressure sensor in the car seat, we'd put it under its butt, right? Where it's sitting. It's the same thing that you have in your car now, right? Because the airbag light goes off. So what that is, let's see if I've got some. Okay, so what that is basically a sensor like this. Not stainless steel like that, but they just make it flat. So if you can set it to 10 pounds. So if the car would turn off and there was still pressure in the car seat, yes, you could start the car, AC would go on or something like that. So the other thing they use is it's called a load cell. It's basically the same type of thing, it's just a mini scale. So the difference, what would be a good example? If you think about like a lawnmower, for example, you have to be sitting on the seat for it to run, right? So when the seat goes up, you can not run it anymore. In a car, they use a load cell in that application, they use a switch, just on, off. Is someone here or not? That's why you can put like 2 bricks on there and it'll still run. So in a car setting, they actually use a load cell because that gives you a consistent feedback of what the weight is in that seat. So if there's something 20 pounds in there, it won't turn on the airbag. Whereas a lawnmower, it would just be on or off. All right. Any questions on this one or? No? All right. All right, so here is another company called Hexoskin. So these last couple are kind of focusing on athletes. Where I have seen it's either based on the garments based on performance of an athlete or healthcare focused a lot of times. And this particular one is focusing on your workout. So they kind of laid it out a little differently. So you can see the cardiac sensors. They've got one around the waist and then one around the heart, like a normal, I guess, heart rate monitor. So what would they use for the cardiac sensor?
This would be like an accelerometer, right?
Yep, because it's again just bumping, right? You don't need 9 degrees to fully track it, it's just X, Y. How about the breathing? Same thing? Yep, could do the same thing. What they actually used was the piezo film. So when they used that film, they could, because if you use just one sensor, you're going to have to put it on a little circuit board and it's going to be in one place, right? You can put it right over the heart or wherever. What they did with the film was wrap it around the whole front of the body and the bottom. So you get your chest movement, you get your stomach movement, and that just makes it more accurate. So they basically did 2 sensors instead of 1, and they used the piezo film to cover more mass. And then we get to the movement sensor. So why do you think they put the movement sensor on the hip? Exactly, right? So if you're stepping, it's just for steps. It's just for same thing like your Fitbit will do. So one thing that they didn't do on here that they do on the Fitbit and a lot of wearables. So what do you think they would use for a sensor telling you how many flights of stairs you went up? Right? A little bit different. We haven't talked about it yet. Okay, so what they actually do there is use a barometric pressure sensor. So when you are in a plane and you're coming down to land, once you hit 10,000 feet, right, you get this pressure in your ears, right? So that's barometric pressure. So for every flight of stairs that you walk up of, that pressure in the environment changes, whether you're in a building or outside. Same thing if like a big storm comes in, that pressure in the atmosphere changes. So what they actually did was put it on a person. So they can take that pressure rating, combine it with your steps, and that's how they can tell you how many calories you burned or how effective you were in your workout. So again, pretty cool and very affordable as well. I think those sensors, again, are maybe $2, something like that.
So Brian, if I can ask, different than the Mimo, which is embedded in that turtle, and then that sensor is taken off and the onesie is washed, based on the variety of different sensors incorporated into this garment, how would they then have to treat? Is the flexible one washable?
Yes, so that's again one of those that I talked about was sealed. That's like the best version of that.
Would be then sealed.
Yeah, but you can kind of see she's got this unit on the side and the wire, so that's all detachable. So the two that are embedded are going to be the breathing and the cardiac sensors, and they don't really open it up to see, but what I would imagine is that they probably put a plastic seal around it and then did the wiring internally and things like that just to protect it. So I would imagine that's always going to be a huge struggle, is to find out how to contain that.
Yeah, 'cause
from
especially
water.
with an active where people would wash it more.
Yeah, exactly.
than maybe.
Yeah.
For the plastic seal, you said, exactly how long would that last?
There's different criteria. So there's a couple different standards so basically you're an engineer, you finish your device, you have to go get it certified. There's labs throughout the country. So they call it, I think it's IEC some number, I can't remember the number. So through that test, you test for waterproofing up to X amount of years. So they run it through a number of cycles, things like that. So, and then you actually get a rating for the product. It's an IP number, IP67 or whatever it is. So it can be different. It just depends what you want to design and test to. It's going to cost you more to make it waterproof for the 10 years than it will be for 5. So it's just kind of, I would say 2 to 3 right now. I don't think it's honestly very good, just because I always run into issues and stuff with customers, just products going bad because of that. But for example, like another really common sensor, not really for what we're talking about, but is just temperature and humidity. So for a lot of our devices, they just put that in there to know the environment, basically. So to protect those components, whereas once maybe a little vent so it can take a humidity rating, they've just encapsulated it, so it's totally waterproof. So something like that, you'll never have to worry about it. And if you do, the supplier of that product would be liable, not your company.
I have a question. The sensor that creates voltage, what's that called again?
Piezo film.
Okay, well that film, like, can you wash that? Does it still create the vibrations from the washing machine or anything? Does it create still voltage?
In that case, if it's not hooked up to anything,
It's just,
it wouldn't. Yeah,
okay, so
yeah,
it has to be hooked up to something to create that voltage.
yeah, yeah. Or something has to receive that voltage and store it. So kind of relate it to, like if you think about solar power, it would be the same thing. You can put a solar panel on your roof, and typically, before Tesla came around and advanced battery technology a lot, that power would have to be used immediately. So if you're not in your home during the day, you couldn't utilize that power from your solar. So now they've created batteries that you can put into your garage, and then that'll store it. So it's really the same concept. They just use solar instead of movement. Oh, one other thing I wanted to talk about on the wearable side. So when they're taking your steps, you're going to go in different paces, right? You'll go from a walk to a run. So one of the things that they do in the software is recognize that cadence and program for that cadence. So especially with the fitness geared things, that's how it's all software on how they recognize, are you running, are you biking, are you swimming? So they take all of that output and they can categorize it by that. It's pretty amazing. when you see these guys work, there's like no lights on. They're at their computer for 10 hours straight. It's amazing. I don't know how they do it, but some companies are better than other. Actually, if Fitbit, I use them as an example a lot, but it's kind of known that their algorithm really isn't very good. They sell everything that they sell based on marketing and how it looks. If you want a $200 wearable, it's gonna be way more accurate compared to the stuff you can buy at Walmart. So it's just kind of what their focus is though. All right, so one of the last ones I had, Adidas actually made these for, I think it was like the track and field team or the rowing team or something like that in Great Britain. So what they did in the pants, their warm-up pants, was basically put a skin temperature probe. So what a skin temperature probe is just a temperature sensor that they flattened out so you can put it on your skin. So when their muscles reached a certain temperature, basically there were heaters and sensors in the pants that make sure you stay at 38 degrees because that's where your muscles are most flexible. So instead of having to take 10 laps to warm your muscles up, throw on the heater, move around a little bit, save your energy for the race. So that was their idea behind these. So not too much in here besides just temperature sensors, but kind of cool. Something that was actually new to me. So, all right, so that is what I have for my presentation. If you guys give me a minute, I want to pull up a couple videos on that Adafruit site. Do you guys have any questions about anything that I can answer in the meantime? I do have a couple little devices that I use. So, okay, so kind of to break away from, I guess, the wearables and everything. What I have, so similar to the Flora, we call these in our industry development boards. So it's something that you can buy and develop off of, right? So if you're gonna go to market with that, you're basically gonna reverse engineer. You're gonna find out everything that's on this board and make your own because it's cheaper than buying it, right? So the same thing, there's another device called an Arduino. And I have a lot of customers, it's this little black circuit board on the bottom here. So it's standard, everybody in the industry uses them. And then suppliers will basically make this green board, they call it a shield. So that just plugs right in and then they just lay it out so you can test their sensors. So this will take you 5 minutes to set up, but if you're gonna make your own circuit board, it could be months before you get it back the way you want it. So these have been new over the last maybe 5 to 10 years, just much easier to prototype with and test out. So the one I have, this cable is actually taking our temperature and humidity in the room. This little gold guy here is CO2. And then dust and like fine particles, smoke sensing. So what we basically, you guys can just pass it around. Basically what we do with that, if you think about a room like this, when we're full, we're gonna put off more CO2. So what do you wanna do with the temperature in a full room? Typically cool it, right? More people warms it up. So as far as building automation, where they were once just taking temperature, set your temperature, you get a little feedback. They're taking CO2 into effect and automating it. So if like a big room I work in, there's probably like 300 people that sit in my office. So when we all leave at the end of the day, during the night, there's hardly any CO2 in there. So those sensors actually calibrate to that lowest level, so they're always accurate. They calibrate themselves every 24 hours, and they're specifically for like a building.
Are there applications for versions of that track pollutants? We were talking in
Yes.
class the other day, we were talking about athletic wear and we were talking about the biking industry and joggers, people who work in cities who are exposed to a lot of, you know.
Yep. Asia has a really big market for that right now because they have a huge pollution problem, right? So what I've seen more, I saw one company where it's just a little stick basically, And you just hold it up in the air, press the button, and then it's going to give you a red, yellow, or green on whether or not basically you should breathe the air. Put on your mask or whatever.
We laugh, but unfortunately it's true.
It's kind of scary.
Want to make clothes that light up when you move? It's easy with Flora, Adafruit's wearable electronics platform.
I love
that we'll
this
use
girl.
in today's
This
project,
Becky girl,
the
she
Sparkle
is
Skirt, which is
honestly a
activated by the
genius.
Flora
No one
motion
had
sensor.
these little wearable boards
12
before her.
color-changing LED pixels
She's
light
one of
up
the
skirt
only
from within,
women-owned
all connected
engineering
with conductive
companies
thread
in our
to the Flora
entire
main
industry.
board. The accelerometer senses motion and triggers the LEDs to twinkle, any color you like. Look at our complete tutorial on the Adafruit Learning System and follow along to electrically bedazzle your own wearable project. And it doesn't have to be a skirt either. This circuit and code would work great on a hat or a belt buckle, and I even made this collar for my dog Olive. The code for this project is easy to understand, and you can adjust the sensitivity to motion with just one number, so you can be as flashy as you want to be. When it comes time to clean it, just remove the battery and gently hand wash. Just be sure to let it air dry completely before plugging the battery back in. So I think you're ready to go out there and make your own sparkle skirt to light up the dance floor. And then share your wearables creations with us on our weekly show and tell on Google+. And don't forget to subscribe to our channel here on YouTube for more wearable videos.
Okay, so one
every
cool
Wednesday.
thing that Adafruit also does is that they open source all of their software. So you can go to her project with the skirt, see how she did all the software, and then just make little tweaks to it without having to go through and rewrite it, which takes a very long time. So she has definitely, I guess, kind of made the way for a lot of these wearable eval boards. And there was one I really wanted to show you. Let's see if I can find it. And this was a pretty good example of also what I was seeing with like the dance groups and stuff like that. It's really the same concept, just software differences. Okay, so this kind of gives you, I was going to show this just for that 9 degrees of freedom. You get an idea how closely it can track the movement there. Where, again, that just accelerometer by itself is just going to be like X, Y, very basic.
The summer sun can be really intense, and I know I could certainly use help to remember to reapply at my SPF.
I have a feeling
So
she
today
needs
we're
to use a
building
lot of
sunscreen
sunscreen.
reminder hat with the UV index sensor and Flora, Adafruit's powerful sewable
But see, when I was
microcontroller.
talking about the placement, that's another
We'll
big
stitch up
thing
the
with the
circuit with
sensors
conductive
is
thread,
having
no
it in the
soldering
right
required,
spot
and then
to
program it to play a song
get
when
that
you've been out in the
sensor
sun long
read.
enough to need your protection
Medium.
renewed. Let's get started.
Find a spot on your hat to build your circuit. You want the sensor to face the sky and the piezo to be near your ear.
So
I'll
that
put the
little
Flora
round black
battery
thing
behind this ribbon.
is made of piezo as well, but it
Pure
actually
piezo
emits
by
a
pulling
sound
its
rather
legs
than a
with a pair of
voltage, so it
pliers.
gives you a little
This will make
buzz.
it easy to stitch with conductive thread. First, attach Flora to the hat with plain thread, then start sewing conductive traces to connect each leg of the piezo and all 4 connections on the UV index sensor. Check out the complete tutorial for this project on the Adafruit Learning System, where you'll find a circuit diagram and Arduino code for uploading to your own sunscreen reminder hat. It's easy to adjust the UV threshold and how often it alerts you. Stitch the ribbon back on to hide Flora and the battery, and wear it out next time you're poolside or at the beach to help you remember to reapply.
This open source project can help kick off your own custom hat. What features would you add? Maybe a GPS for tracking your sun-filled journey, or a NeoPixel notification for using at a loud outdoor festival? And let us know in the comments below. Thanks so much for watching, and don't forget to like, share, and subscribe for more wearable electronics from Adafruit.
Okay, so did you guys kind of notice she was talking about conductive thread? Do you guys know what that means? Yeah. Right? Okay. So anybody that doesn't, it just means where before you'd maybe have to use like a cable or a thicker wire or something. Okay, and this was the cool scarf. She did an umbrella as well, but I thought the scarf was
match
kind
your
of
outfit using Flora, Adafruit's wearable Arduino compatible platform. This is version 2. It's got more LEDs and uses flexible diffusers to more evenly light up the even warmer wool scarf. You know, 'cause it's freezing outside. The Flora color sensor picks up the shade of your favorite sweater. You can find the instructions for this project on the Adafruit Learning System. The link is in the description below. There you can also find and download the 3D file for the diffusers. Print them in white NinjaFlex filament while you make the rest of the scarf. Use a zigzag stitch on your sewing machine to capture 2 lines of conductive thread or yarn on a regular ribbon. These will be your power and ground buses for the pixel chain. Then, on the other side of the ribbon, starting at the end of the pixel chain, start adding pixels. Test each one as you go, verifying it also animates the next pixel in the chain. The more pixels you add, the more power is used. You may need to reinforce some connections with more conductive thread or ribbon. We made this long scarf on the knitting machine, but you can also recycle an old sweater. The flexible diffusers help spread out the light inside the scarf, and they're flexible enough that you can't even feel them. Version 2 of the chameleon scarf is a circle, so after turning it right side out, connect up the power and ground buses at the ends of the ribbon, which helps for power distribution. The flora is hidden by the overlapping ends of the scarf, but it's easily exposed for sensing a new color and changing the battery.
Thanks so much for watching, and subscribe for more wearables from Adafruit.
So this was kind of a good example to me also when we talked about power, right? So she's got that big long strip of LEDs. So you're gonna need probably like 2 AA's or 2 AAA's to power all of those LEDs, where if she would maybe just have 1 or 2, you could probably use a little coin cell and sew it right into the scarf or something like that. So. I didn't really talk about GPS too much because it's not a sensor, and honestly I don't really know too much on specifics about them. I would have a feeling it's GPS, right? Where are you? What are you doing? How fast are you moving type of thing. She did one helmet where they used it, and it was with the GPS they could like link into Google Maps or something, and you could do basically directions with it through the helmet. So it would give you a blink on the right side if you were supposed to turn right, a blink on the left. All right, I think that's pretty much all I've got. I mean,